Cosmos, by Carl Sagan. Introduction. Have you ever looked up at the night sky? Truly looked? Away from the city lights, on a clear, moonless night, you can see a river of faint light spilled across the heavens. The ancient Greeks thought it was the milk of a goddess. The Kung people of the Kalahari Desert call it the backbone of night. And for most of human history, that's what the stars were. Beautiful decorations, myths, legends. They were lights in the sky, nothing more. We lived our lives on this small world, believing we were the center of everything, the main characters in the cosmic play. But one of the greatest adventures of our species has been the slow, courageous journey of discovering that we were wrong. The book we're exploring today, Cosmos by the brilliant astronomer Carl Sagan, is the story of that adventure. Published in 1980 as a companion to his landmark television series, it has sold over 5 million copies and has been read by people in every corner of this planet. It's more than a book about science, it's a story about us. It's the story of how we, a species born of star stuff, woke up one day on a tiny world and began to wonder where we came from and where we are going. Carl Sagan wasn't just a scientist, he was a poet of the cosmos. He had a rare gift for making the grandest, most complex ideas feel personal and deeply human. He believed that science wasn't just for academics in ivory towers, but for everyone. It is our birthright. Today, I'm going to share with you the heart of his masterpiece. This isn't just a summary, it's an invitation. An invitation to join a journey that will take you from the shores of the cosmic ocean to the edge of forever. By the end of our time together, you won't just know a few more facts about the universe. You will feel, deep in your bones, that you are a part of it. You will understand that the same laws that shape the galaxies also shape you, and that the story of the universe is your story. So, let's begin. Let's set sail on the cosmic ocean. Book summary. Our story starts in a place you might not expect. Not in the cold vacuum of space, but on a quiet beach in Japan, where fishermen tell a strange legend. For centuries, they have caught crabs with markings on their backs that look, disturbingly, like the face of a scowling samurai warrior. The legend says these are the ghosts of the Haika clan, defeated in a great naval battle here in the year 1185. The fishermen, out of respect for the fallen warriors, throw these crabs back into the sea. They do not eat them. This raises a beautiful question: how did the face of a warrior get etched onto the shell of a crab? The answer, as Carl Sagan explains, is not magic. It's evolution, guided by an unseen hand. The patterns on a crab shell are inherited. By pure chance, long ago, a crab might have been born with a pattern that looked, just slightly, like a human face. A fisherman, pulling up his net, might have been startled. Maybe he felt a twinge of superstition and threw it back. Now, think about what happens next. If you're a crab with a normal-looking shell, you get eaten. Your genes don't get passed on as often. But if you're a crab with a shell that looks a little like a face, you get thrown back into the ocean. You live to have more baby crabs. Over hundreds of years, the crabs with shells that looked most like a samurai face were the ones that survived. The fishermen, without even realizing it, were acting as the agents of selection. They were breeding samurai crabs. This process is called artificial selection. It's how we got dairy cows from wild oxen, and every breed of dog from the wolf. Humans decide which traits survive. But this leads to an even bigger idea. If humans can create such dramatic changes in animals and plants in just a few thousand years, what can nature itself do, working over billions of years? This, Sagan tells us, is the key to understanding all of life. The process is called natural selection. Nature is the one doing the selecting. The environment is the fisherman. And the result is every living thing you've ever seen: the hummingbird, the giant sequoia, the bacteria in the soil, and you. Evolution is not a theory, it is a fact. And it is the first great piece of the puzzle to understanding our place in the cosmos. It tells us that all life on Earth is connected. We are all distant cousins. You and the oak tree in your backyard share a common ancestor. We are all, as Sagan beautifully puts it, one voice in the cosmic fugue. The music of life on Earth is intricate and beautiful. But is it the only song? Or are there other voices, other melodies, playing out on other worlds scattered across the light years? To answer that, we have to ask a more fundamental question. What is life made of? If you want to make an apple pie from scratch, Sagan says, you must first invent the universe. It's a playful way of making a profound point. Every ingredient in that pie, the carbon in the apple, the oxygen in the water, the nitrogen in the wheat, is made of atoms. And where did those atoms come from? Except for the very simplest, every atom that makes up you, me, and the world around us was forged in the heart of a star. A star is a great cosmic kitchen. It takes the simplest element, hydrogen, which was created in the Big Bang, and under immense pressure and heat, it cooks it into heavier elements. Hydrogen becomes helium. Helium becomes carbon, oxygen, and all the rest. When a massive star dies, it doesn't just fade away. It explodes in a cataclysmic event called a supernova, an explosion so bright it can outshine an entire galaxy. In that final, violent act, it scatters the elements it created across space. The iron in your blood, the calcium in your bones, the carbon that forms the basis of all life on Earth, it was all created in a star that lived and died billions of years ago. You are, quite literally, made of star stuff. This is the second great piece of the puzzle. The matter of life is not rare or special. It's spread throughout the cosmos. The stuff of life is everywhere. This idea, that the universe might be brimming with life and that we are not the center of it all, is not a modern one. It's an ancient idea, born in a place and time that Sagan calls the first great awakening of our species. It happened about 2,500 years ago, in a region called Ionia, on the coast of modern-day Greece. For thousands of years before, people had looked at the world and seen only the whims of the gods. An earthquake was the anger of Poseidon. A thunderstorm, the wrath of Zeus. Nature was a mystery, and the gods were unpredictable. But in Ionia, a new idea took hold. It was one of the most revolutionary ideas in human history. The universe, the Ionians said, is not run by capricious gods. It is governed by a set of natural laws. And the most incredible part? We can understand those laws. This was the birth of science. A man named Thales was the first to suggest that the world could be understood without invoking the gods. He believed everything was made of water, which wasn't quite right, but his method, seeking natural, not supernatural, explanations, was a giant leap. Another Ionian, Anaximander, argued that life had arisen from mud and that humans had evolved from other, simpler animals. He proposed that the Earth was a body hanging in space, held in place not by pillars or giants, but by being equally distant from everything else. And then there was Democritus, who gave us the idea of the atom. He imagined that if you cut an apple in half, and then in half again, and kept going, you would eventually reach a tiny, uncuttable particle. He called it atomos, which means uncuttable. He said that everything, including us, was just a collection of atoms moving in a void. Nothing exists, he declared, but atoms and the void. These Ionian scientists were laying the foundation for our modern world. And nowhere was this spirit of inquiry more alive than in the greatest center of learning in the ancient world, the Library of Alexandria. For centuries, the library was the brain and heart of civilization. It was the first true research institute. Scholars there studied everything. They collected books from all over the world. It's said that any ship docking in Alexandria was searched, not for contraband, but for books. The scrolls were copied and the originals kept for the library. It was here that a man named Eratosthenes performed one of the most elegant experiments in all of history. He was the director of the library. He read in a papyrus book that in a town to the south called Syene, On the longest day of the year, at noon, vertical sticks cast no shadow. The sun was directly overhead. This was a simple observation. Most people would have ignored it. But Eratosthenes was a scientist. He wondered, did a stick in Alexandria cast a shadow at the exact same moment? He decided to check. And he found that it did. Now, how could this be? How could a stick in Syene cast no shadow, while a stick hundreds of miles to the north cast a significant shadow at the same time? Eratosthenes realized there was only one possible answer. The surface of the Earth is curved. And not only that. The difference in the shadow lengths could tell him how curved. The sun's rays are parallel. By measuring the angle of the shadow in Alexandria, he found it was about 7 degrees. 7 degrees is about 1/50th of a full circle. He knew the distance between Alexandria and Syene was about 800 kilometers. So, he reasoned, the full circumference of the Earth must be 50 times that distance. His calculation, 40,000 kilometers. He was almost perfectly right. With nothing but sticks, eyes, feet, and a mind open to curiosity, a man in ancient Alexandria measured the size of our planet. This was the power of the Ionian awakening. Humans were beginning to grasp the cosmos. But the greatest of these ancient scientists was a man from the island of Samos named Aristarchus. He took the next, most daring step. He argued that the Earth was not the center of the universe. He proposed that the Earth was just one of the planets, and that all the planets revolved around the sun. He also suggested that the stars were other suns, just incredibly far away. He was right. But the world was not ready for his ideas. They were too radical. It seemed obvious that the Earth was stationary and the heavens revolved around us. The insights of Aristarchus were forgotten. And then, tragedy struck. The classical civilization that had created the Library of Alexandria began to crumble. Slavery, mysticism, and a growing hostility to learning eroded the spirit of Ionia. The library, the repository of centuries of knowledge, was destroyed. We don't know all the details, but we know the result. Only a tiny fraction of the book survived. The work of Aristarchus, which contained the blueprint of the solar system, was lost. It was, Sagan says, as if our entire civilization had undergone brain surgery. Most of our memories were wiped clean. The world slumbered for 1,000 years. Science was silenced. The reawakening began in the Renaissance. A Polish cleric named Nicholas Copernicus rediscovered the ideas of Aristarchus. He, too, proposed that the sun was the center of the solar system. The idea was still dangerous. The Church condemned it. But the seed had been planted again. And this brings us to one of the heroes of Sagan's story, a brilliant, stubborn, and deeply religious man named Johannes Kepler. Kepler lived in the early 17th century, a time of turmoil and superstition. He was trained as a theologian, but he was captivated by the mystery of the heavens. He believed that God was a master geometer, and that the universe must be built on principles of mathematical beauty and harmony. Kepler inherited the best astronomical observations of his time, compiled by the great Danish astronomer Tycho Brahe. For years, Kepler tried to fit Tycho's data for the planet Mars into a circular orbit, the perfect shape that everyone since the ancient Greeks had assumed was right for the heavens. But it wouldn't fit. There was a tiny discrepancy, just 8 minutes of arc, a sliver of the sky so small you couldn't see it with the naked eye. But Kepler's integrity as a scientist would not let him ignore it. He wrote that those 8 minutes pointed the road to a complete reformation in astronomy. He abandoned circles. He tried ovals. Finally, in desperation, he tried the formula for an ellipse. It fit perfectly. Kepler had discovered the first law of planetary motion. Planets move in ellipses, not circles. He went on to discover 2 more laws, describing how planets speed up as they get closer to the Sun and showing the beautiful mathematical relationship between a planet's distance from the Sun and the time it takes to complete an orbit. For the first time, the true clockwork of the solar system was revealed. The harmony of the worlds, Kepler called it, was not the mystical perfection of circles, but the subtle, elegant harmony of physical laws. He had read the mind of God, but the language was not what he expected. Kepler's work paved the way for Isaac Newton, who, in a breathtaking leap of insight, realized that the force that makes an apple fall to the ground is the same force that holds the moon in its orbit and keeps the planets on their elliptical paths. He called it gravity. Newton showed that the laws of physics were not just for Earth. They were universal. The same rules apply on Earth as in the heavens. This was the final step in the journey that began with the Ionians. The Earth was not a special, tainted place, separate from the divine heavens. It was a part of the cosmos, subject to the same laws as everything else. This new understanding, this cosmic perspective, is what allows us to do something our ancestors could only dream of. It allows us to leave our world. In the 20th century, we finally built the ships to sail the cosmic ocean. And our first great voyages of discovery into the outer solar system were made by two remarkable robot explorers, the Voyager spacecraft. Sagan describes the Voyager missions with the wonder of a child and the precision of a scientist. These were our modern-day caravels, venturing into the unknown. Their journey was a direct descendant of the great sailing ship voyages of the 17th century, a time, especially in Holland, when exploration and science went hand in hand. In that era, Christian Huygens, a Dutch astronomer, used the newly invented telescope to discover the rings of Saturn and its giant moon, Titan. He was one of the first to speculate seriously about life on other worlds. Now, 3 centuries later, Voyager was on its way to see those worlds up close. The journey was epic. The spacecraft flew past Jupiter, a world so vast that 1,000 Earths could fit inside it. It sent back stunning images of the Great Red Spot, a hurricane larger than our entire planet that has been raging for centuries. But the real surprises came from Jupiter's moons. These were not just dead rocks. They were worlds in their own right, each a unique traveler's tale. There was Callisto, its ancient surface cratered like our moon, a record of the violent youth of the solar system. There was Ganymede, the largest moon in the solar system, with strange grooves and valleys crisscrossing its icy surface. There was Europa, smooth as a billiard ball, covered in a vast ocean of liquid water hidden beneath a shell of ice. A global network of cracks, like a shattered eggshell, suggested a dynamic world beneath. Could there be life in that dark, hidden ocean? We still don't know. And then there was Io. Before Voyager, we knew it was a strange, reddish color. But what Voyager found was beyond anyone's wildest imagination. Io was covered in active volcanoes. Not volcanoes of molten rock, like on Earth, but volcanoes of molten sulfur, spewing plumes of gas hundreds of kilometers high into space. It was a world perpetually turning itself inside out. The Voyager spacecraft, their primary missions to Jupiter and Saturn complete, are now sailing on, out of the solar system, into the great dark between the stars. They are the first emissaries of Earth to the cosmos. Affixed to each is a golden phonograph record, a message in a bottle cast into the cosmic ocean. It contains 115 pictures of our world, greetings in 60 human languages, the sounds of earth, wind, rain, a baby crying, a chimpanzee's call, and 90 minutes of music, from Bach and Beethoven to Chuck Berry. It is a piece of our world, a testament to who we are, hurtling through the void. It will last for 1 billion years. The journey of the Voyagers is a symbol of our own journey. We began as wanderers, and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean. We are ready, at last, to set sail for the stars. But this brings us to the final, and most profound, part of Sagan's message. Our journey into the cosmos is inseparable from our journey within ourselves. From the cosmic perspective, our planet is a tiny, fragile stage in a vast arena. From space, you see no national boundaries, no divisions of race or religion. You see only one Earth, a pale blue dot, the only home we've ever known. And on this small stage, we have developed a frightening capacity for self-destruction. The same technology that allows us to explore the planets has given us the power to extinguish all life. The rocket boosters that launch our spacecraft can also deliver nuclear warheads. Sagan asks the most important question of our time: who speaks for Earth? In the face of our shared dangers and our shared destiny, our tribal loyalties and national chauvinism seem petty and suicidal. The cosmic perspective teaches us something about ourselves. It teaches us that our survival depends on our ability to see ourselves as a single species, the inhabitants of one small planet. The story of the cosmos is the story of a universe that has, in at least one small corner, grown to self-awareness. We are the means for the cosmos to know itself. Our minds, our curiosity, our relentless drive to understand, these are not just human traits. They are cosmic traits. The atoms within us have been on a 15 billion-year journey. They were forged in stars, scattered across the galaxy, and eventually came together to form the Earth, life, and finally, us. We are, in the deepest sense, children of the cosmos. Our obligation to survive and to cherish one another is owed not just to ourselves, but to the universe from which we sprang. The exploration of the cosmos is not a luxury. It is a necessity. It is a voyage of self-discovery. And it is a responsibility. Commentary. Reading Cosmos is not like reading a textbook. It's like having a conversation with a brilliant, kind, and incredibly wise teacher who wants nothing more than for you to share in his sense of wonder. The feeling that stays with you long after you finish the book is one of profound connection. Sagan's greatest gift is his ability to weave together science, history, philosophy, and a deep sense of humanity into a single, cohesive story. He shows us that the scientific endeavor is not a cold, sterile process of collecting facts. It is a passionate, courageous, and deeply human adventure. The stories of Eratosthenes, Kepler, and Champollion are not just historical anecdotes, they are parables about the power of human curiosity and the courage it takes to challenge conventional wisdom. The central message of Cosmos, for me, is the power of the cosmic perspective. In our daily lives, we are so often consumed by our own small worries, our own ambitions, our own tribes. The universe seems remote and irrelevant. But Sagan reminds us that we are not separate from it. We are in it, and it is in us. To look up at the stars is to look back in time. To understand the life of a star is to understand the origin of the atoms that make up our bodies. To see our planet as a pale blue dot is to understand how precious and fragile our home is. This perspective is not meant to make us feel small or insignificant. On the contrary, it is deeply empowering. It tells us that in a universe of 100 billion galaxies, our world, and every being on it, is rare and precious. In 100 billion galaxies, you will not find another. That single sentence is one of the most powerful arguments for compassion and tolerance I have ever heard. If there's one practical thing you can take from this book, it's this: practice curiosity. The Ionian awakening began because a few people were not satisfied with the easy, conventional answers. They dared to ask why. They dared to observe the world for themselves. That spirit is the engine of all progress, not just in science, but in every aspect of our lives. So, here are a few simple ways to bring the spirit of Cosmos into your own life. First, the next time you have a clear night, go outside and just look up. Don't just glance. Really look. Find a constellation. Think about the fact that the light from those stars has been traveling for years, decades, or even centuries to reach your eye. Think about the fact that you are made of the same stuff as those stars. Let yourself feel that sense of awe. Second, practice perspective. When you're faced with a problem or a conflict that feels overwhelming, try to see it from 10,000 feet up. Then from orbit. Then from the moon. From the edge of the solar system. Most of our terrestrial squabbles shrink into insignificance when viewed against the backdrop of the cosmos. And finally, Never stop asking questions. Never stop learning. Our journey of discovery is just beginning. We are the first generation to be able to truly explore the solar system. We are the first to be able to listen for messages from the stars. It is an incredible time to be alive. I've done my best to share the essence of cosmos with you today, but let me be honest. A summary is like looking at a postcard of the Grand Canyon. It gives you a sense of it, but it's nothing like standing on the rim yourself. The real magic of this book is in the journey it takes you on, in Sagan's beautiful prose, and in the quiet moments of reflection it inspires. This summary is just a map. If anything we've talked about has sparked your curiosity, I urge you to take the voyage yourself. Reading Cosmos isn't just about learning, it's an experience that can fundamentally change the way you see the universe and your place within it. And if you found this journey valuable, please take a moment to subscribe and share it with someone you think might also enjoy setting sail on the cosmic ocean. It helps us continue to explore the ideas in these incredible books. Let's keep growing and wondering together.